Okay, Assalamu alaikum and Bismillah Rahman Rahim. So, this is about lab 1 for our for our lab part of the course, data structures and object oriented programming. So, as you know, like we haven't had a class yet about data structures and object oriented programming, but we want to get started with the lab part of it. Uh, about the theory part, I will start uploading the video lectures for the theory part, but this lab, particularly this lab, it is independent of the theory that we are going to talk about in this course. So this course it has like two parts. One is about object-oriented programming. Uh, it is a way of programming or a paradigm of programming computers or thinking about problems that we can solve using computers. And the other part is about data structures. So data structures are also very important because almost every software that you use, every piece of software that you use, in order to make that software work, so there are plenty of data structures in action behind the screens, and it is important to know those data structures and how you can create those data structures on your own. So we'll talk about that in this course, but this particular lab is about something that usually comes towards the end of a first course on computer programming, and this is about what we call structures or structs. You can call them as a shortcut in C++. So in this particular lab, we are going to find out what structures are, and we are going to understand like how to use those structures in C++. And now I'm using the term structure, but they are also called structs in C and both C and C++. Now structs are used to create new data types. Uh, there are certain built-in data types in C++. You must have used those data types. You must be aware of those data types, for example, int, float, character, bool. So these are all built-in data types. And then there may be situations where the built-in data types may not be enough, and you would be required to create new data types, or you would at least you would like to have new data types so that you can deal with different types of data. We'll look at a couple of scenarios in that regard. We'll look at a couple of examples. So first, like, understand what structures are. If you haven't already studied this thing in computer programming, so let's study what structures are. So structures or structs, they are aggregate or composite data types. Okay, so aggregate and composite. So composite also means like it is composed of more than one type of data, and aggregation is also basically a collection or putting together different types of data. So in a structure, what we do is we take the built-in data types or any other structure, and we take a couple of them or more than that, we put them together to create a new data type. Okay. So say for example, like, you must be aware of complex numbers. Now a complex number, as you know, it has two parts. One is the real part and the other is the imaginary part. The real part of a complex number can be any real value, and the imaginary part of a complex number can also be any real value. Like, its magnitude can be in any real value, but it is along the imaginary axis in the complex plane. Okay, and the real part is it can also have its magnitude can be any real value, but it is along the real axis in the complex plane. So a complex number is basically an ordered pair. It has the real part and the imaginary part. So you can have, like, if you want to create a structure that can be used to store complex numbers, so you can create a structure, let us call it as my complex or simply complex, and it can have two data members. One data member would be the real part of the complex number, it would be of type double, and the other data member would be the imaginary part of the complex number, it would also be of type double. Okay, so we can combine two double variables in order to create a new structure that can be used to store complex numbers and again to process complex numbers. Similarly, we can have other structures. For example, in this particular lab, we ask you to create a structure to store time. Okay, so we do not have, say, a variable to store time. So we do process time, we do process intervals on computers, like we store time and we store intervals and we find the difference between two intervals. Okay, so we do not have a proper data type for that. So you can create a data type for that, a structure for that that can store interval or time. Okay, now we will create one such simple data structure, structure to store time intervals and to process time intervals. We will do that, and then we'll ask you to create the my complex data type. Similarly, like you might want to uh, process rational numbers using or fractions using your computer. So right now we do not have like a data type that can store fractions. A fraction can always be reduced to a decimal value or to any real value. So we have data types that can store real values. Like we have this the float data type in C++ and the double data type, and these data types can be used to store real values uh, or fractional values in their decimal representation. So we can do that, but we do not have a data type that can directly store fractions as a numerator and denominator, and that can directly operate on those fractions. So you can create one such structure in C++ which can directly deal with fractions. Okay. So in this course, like in most of the labs, we will be working with this my complex type and fractions type, and all these labs are kind of progressive in nature. Progressive in nature से मुराद ये है कि whatever you do in the first lab, usually in the next lab you build upon that. Okay, so do not like throw away your code or whatever you do in your first lab. Whatever you learn in your first lab, it applies very much to the next lab, and the code that you created in the first lab very much is required in the next lab. So this is how we usually proceed in this course. So you should, whatever you do in your current lab, you should save it for your next lab. You'll definitely require it in your next lab. Now, a thing or two about structures. A structure cannot be a member of itself. So if you are creating a structure, so you can create a structure by aggregating different data types. The types that you use, that you combine to create a new structure, they are called the data members or members of that structure. Now, the member of a structure can be any data type other than the structure itself. So if you are creating, say for example, a my complex data structure, structure. So the my complex structure cannot have a member of type my complex. Okay, it can have a pointer to a my complex structure as a member, but it cannot have the my complex member as a my complex structure as a member of itself. So if a structure has uh, for example, if we are creating a structure my complex, or if we are creating a structure say time or interval, and one of the members of that structure is a pointer to the structure itself, so those structures are called self-referential structures. Why? Because they refer to um, themselves using a pointer. Okay, so these structures are called self-referential structures. Now we'll return to these things in much more detail in the subsequent labs. So even if these things do not make a lot of sense to you right now, do not worry about it. You can always ask, and I'll try to repeat. And while creating or writing the code for this lab, I'll try to repeat these things or show these things to you. Uh, that would make it clearer. But even if you don't completely understand it right now, so that's fine, you will get it later on. Now I have shared this handout with you on Google Classroom. So this handout basically tells you this is supposed to be a self-contained document. So back in the normal days, I used to ask the students to get a printout of it, and after getting a printout of it, they would write their name and registration number and section here, and then they would start reading out. So we start out with the objectives of this lab, and then we list down the deliverables, like what are you supposed to do in this lab, and once you are done with that, what would be your evidence? What are you going to deliver or submit to the instructor? So this is what we mentioned here. Now the objectives, I put these objectives here as well, and we went through it to understand the use of structs in C++, to create new user-defined types using structs, and to create member functions within structs to directly process data members. So we can create member functions within a structure, and those member functions could then operate on the members of the structure directly. Okay, so this is something that we are going to use later on, and when we are writing our classes and objects. So when we are writing our classes, so this is something that we are going to do later on. And structures and classes, they share a lot of similarities. Okay, so in fact they share, they are extremely similar. There are plenty of things that you can do with both structures and classes, and at times it feels that the difference only is in basically these uh, these keywords, like one is called a struct and the other is called a class. Otherwise, whatever you can do with a class, you can nearly all of that you can do with a struct. So these are the objectives. This is what we want to achieve. So hopefully after you're done with this lab, you should be able to do these things. Okay, so you should try to achieve these objectives, and we try to do it using these tasks. Okay, so the first task that you'll do in this lab, and I'll also demonstrate it to you, is creating a new data type called my time. So we will create a new data type, my time. My time can be used to store time. Time means instantaneous time. So say for example, right now it is 5:43 a.m. So we can specify the hours, the minutes and seconds here, and it can also be used to store intervals. Intervals means like duration. So if the duration of this class, say for example, is 3 hours, so we can have 3 hours and 0 minutes and 0 seconds, something like that. So we want to create a data type that can be used to store time or to store intervals. And again, later on, like we would like to be able to do some operations on this data structure as well. So you can read through this thing. This will help you understand different things. Some of these things I might have talked about, some I might not have, so you can read through it. I'll basically try to demonstrate like whatever we have talked about here. I'll try to demonstrate. Now, in order to understand like this document, so if you look here, I have added a comment, and in the comment I have written main.c++. So whatever is written here, this is basically going to be inside this particular source file, main.c++. In this lab, we'll be creating only one source file, but in the subsequent labs, we'll be doing multi-file programming. So we'll have a header file where we would put our class definition declarations. Then we'll have two different source files. One will be our main source file, where we will have our main program, and the other source file would have our class definitions. Okay. Right now in this lab, like we are only using one source file, the main.c++ source file. So all the code that we create, it's going to be inside this particular source file. Okay, but later on we'll be doing multi file programming, so we will have multiple source files. So pay attention to this thing. So this comment basically tells you that this is the code that will go into the main.c++ source file. Okay, now in this particular code, like we create a new structure that is used to store time or time intervals. Okay, and time is limited only to hours, minutes, and seconds. So whenever you like talk about time, you talk about these three things: hours, minutes, and seconds. Okay, so this tells you that if you're going to create a structure that needs to store time, it should have at least these three data members. Okay, and these data members are of type integers. We do not need real values or double values here, so we can use integer values to store these different values. So my time structure is going to have three data members. Now these three become data members of the structure. The hours, minutes, and seconds. These are all of type integer, three variables of type integer, and these three variables are members of this new structure that we create. Okay, so what will happen when we create the structure? यानी क्यों हम ये structure create कर रहे हैं? ये structure हम इसलिए create कर रहे हैं कि we want to have data type जिसमें हम time को store कर सकें और उसको process कर सकें. So जैसे कि just like the way we create variables of type int, यानी hours is a variable of type int, minutes is a variable of type int, seconds is a variable of type int. Once we define a new structure, we will be able to create variables of type myTime. Okay, and those variables will be used to store time values. Okay, so that is basically the idea of creating these new types. They should be able to store this new type of data, and they should also be able to process this new type of data. Okay, so this is what we are going to do. Acha ji. So let's start. Let us create a project. Let me give you a brief demo in which we create a new structure. We'll create a console application, and I hope like you know this routine. I hope you have used code blocks in computer programming in your course on computer programming, and I hope you're aware of all these things. So I'm not going to repeat these things. So I hope you understand, you remember like what it's like to create a project in using code blocks. So it's very simple. It's not that complicated. I hope like you know this. So let us create a project. We want to save this code. Uh, let's come here to data structures and OOP lab, and here we create a folder code. So always remember, do not store your code on your desktop. You should have a proper directory where you should be able to store your code, and this code is part of lab 1. So let me save it here, create another folder lab 1. Okay, now this is where this code is going to go, and we want to now this project, now usually project title should be meaningful. Meaningful means like it should reflect whatever you're trying to do, or you should give it some fancy name. For example, if you're going to write some software, so that software should go with the name, and that name should be very catchy or fancy, or it should be original. It should also show the purpose of that software. So for example, like so it can be anything, but here in this particular case we'll try to use something that is more meaningful. So let us call it, it may not be that meaningful, but let us call it lab 1, and let us add this mm, word structures to it. So this lab is about structures. So this is our project title. So inside this folder, the folder that we specified here, another folder would be created by the name of lab 1 structures, and all our source files and everything would go into that folder. Okay, so this is the compiler that we use. Keep these settings the way they are and press finish. So your project will be created, and once your project is created, here in the management window or pane, you can see in the under the project tab that you have your project, and inside your project you have your source files, our main.c++ source file. So this file was automatically created or generated by this code blocks IDE. Okay, so like you didn't need to create this source file and add it to this project. It was created by default for you, and this is the code that we already have. So I hope like you know what hash include IO stream means, using namespace standard means, what do all these things mean. So I hope like you know these things. I won't describe this code in detail. I'll simply go directly to what we are supposed to do in this particular course. So we talked about, we said that we are going to create structures here, and structures are basically combinations or aggregations of existing types. Now I hope you are aware of existing types. So you know these are the built-in types in C++. We have int. Okay, so you must have used int. We have float to store single precision floating point values or real values. We have the double data type to store double precision data type floating point values. We have the bool data type, and bool data type is used to store boolean values or logical values, true false values. Okay, similarly we have the character variable, and character variable is used to store single characters, single ASCII characters. Okay, then we have different versions, different types of ints. We have the short int. Okay, short, short, say f. We have the long int. Okay, long int, uh, long int, say l. So we have these different types. Okay, but these are all built-in types. These come built into the C++ compiler. Now they are sufficient for many purposes, but they may be lacking for some purposes. Okay, so say for example, we said like if you want to have a data type through which we can process time. So we do not have such data type in C++. We do not have such built-in data type in C++. We may have structures that other peoples might have created, and we need to import those libraries into our code, or include them into our source code and then use them. Or we can also create our own data type, our own new data type to handle that type of data. So how do you do it? So one way through which you can create new data types is using structs or structures. Okay, structs, like it was available in C, and C++ also like provides that construct, that programming construct through which you can create new data types. How do you create a new data types using structures? So this is how you do. You start with the keyword struct, struct, struct. When you use the keyword struct, the compiler like knows that now you're going to define a new data type. Okay, so what should be the name of that data type? Okay, like we have this data type int, float, double. Okay, so we are going to create a new data type. What should be the name of that data type? Just like int, float, double, bool, like what should be the name of that data type that you can use to create new variables of that type? So we want to have a data type that can store time or time interval. So let us call that new data type as my time. Okay, my time. So first we use the keyword struct. This tells the compiler that we are about to create or define a new user-defined type, a new data type. That new data type is my time. That is the name of that data type. Okay. And then we provide these opening and closing curly braces. So when I just entered the opening curly brace, the closing curly brace, and the semicolon, they were provided automatically. Okay, so this is the autocomplete feature, the code autocomplete feature. Automatically, the code was completed. So this is how you define a new structure. This is a syntax for defining a new user-defined type. Okay, or creating a structure. This is the syntax. You use the keyword struct, and then you provide a name for the new type, and then the opening curly brace, the closing curly brace, and a semicolon. So this is how you define a new structure. Now its definition is not complete, like we did not specify the data members of this structure, but nevertheless, like this is how you start. Okay, so now we need to specify what should be the data members of this structure. Okay, so it is this data structure is supposed to store time, and whenever we talk about time, so we talk about hours, minutes, and seconds. Okay, so we need to have a variable that can store hours. So we say int hours. This is one data member of the my time structure. Okay, int hours. This is one data member of the my time structure. Then we need to have another variable int minutes. This is another data member of the structure my time, and then we have another data member in seconds. Okay, this is another data member of the uh, my time data type or structure. So these are the data members that we want to have in our new type. Okay, so now these are three variables of type integer. We can have structures which can have multiple or different types of variables. For example, like we can have a structure student, say for example. Okay, and student can have different data members of different types. For example, a student can have character array, uh, say a name. The name of the student can be a character array. For example, the height of the student can be a double value, double height, okay, or float height. We do not need that much precision. Float height, or if height is in centimeters, we can have int height. So it would be an integer value. Okay, we can say height is in centimeters. Height is in centimeters. Okay, we can have float weight. Okay, so we can have or it can also be rounded off to an integer value. Like this is up to you, this is up to us. So we can have and there can be other data members of the student structure. So here we have another structure student, and it has these data members which are of different built-in types. So it has a character array as a data member, it has an integer, it has a float as a data member, it can have a Boolean value as a data member. For example, we can have say bool bool what marital status. Okay, so either a student is married or not, so it can be true or false. So we can have these different types of variables as data members of the structure student. So this is what we call aggregation. This is what we call aggregation. We said initially that a structure is basically an aggregate data type. So we aggregate or combine different built-in types or other structures. We can have other structures here. For example, we can have say uh, we do not have time of birth. So right now we have the built-in structure my time available to us. Uh, so let us say we have my time and happy time. When does the student when is, at what time of the day is the student happy? Okay, happy time or class time or any other time. This is just to give you an example that one structure can have another member as a structure. Okay, one structure student, this is a structure, it can have another structure as a member, okay, as a data member. What it cannot have is this thing, like a student structure cannot have a student data member. So this is the structure student, and it has a data member which is student itself. Okay, so let us call it best buddy. This student is basically the best buddy of this student in his or her class. Okay, so every student has a best friend or best buddy in the class, so that is also another student. So this is not allowed in C++. This thing is not allowed. Okay, so one structure cannot have as its member the same structure as itself. So a structure cannot have itself as its data member. So this is the structure student, and this is a member of the structure student which is of type student itself. So this is not allowed. Okay, this is not allowed. This is not allowed. Okay, so let's see if the compiler can say something about it. And we try to do something like this. Okay, so we made a mistake here as well, I guess. So character, yeah. So this is how you declare a character array, and let us recompile it. Okay, so field best buddy has incomplete type student. Okay, so you may note definition of struct student is not complete until the closing brace. Okay, so here the compiler thinks perhaps we are trying to redefine the structure student. Okay, we have not like completed its definition, we are trying to redefine it. So this is basically to say that this is not allowed. You cannot have the structure as a member of itself. What is allowed is this thing, like we can have a pointer. So this is how, I hope you know, this is how you define a pointer, declare a pointer. So now we have best buddy is basically pointer to a variable of type student. It is not the structure itself, it is pointer to a, a, um, a variable of type student. Okay, so there is a difference between the two. Now this thing is allowed. Okay, this thing is allowed. We can have this thing. If you compile this code, so the compiler will not flag any error. So we do not have any error. The compilation went fine. We have plenty of warnings, but this is fine. Now this particular structure student, we can call it as a self-referential. Okay, so this is allowed. Pointer is allowed. Okay, structure not allowed. Structure not allowed. This is a comment that we want to add. Pointer to structure allowed. Pointer to struct allowed. Okay, and this is what we call a self-referential structure. This is self-referential. Self-referential. So the structure student refers to itself. The structure student, it refers to itself. Okay, so this is how it refers to itself using a pointer. Using a pointer, it refers to itself. So this is a self-referential structure. This is allowed. I hope like uh, uh, you understand whatever we did just here. Okay, so this is allowed. You can have it, but the other thing was not allowed. Now let us like let us minimize this thing. We are interested in right now writing this new structure my time. Okay, so this is the new structure my time. Let us use this structure. So this is how you define a new data type my time. Now how can you use it? So in order to use it, you need to create variables of type my time. How would you do that? Just like any other variable. When you wanted to create an integer variable, int a for example, so this is how you do. You use the keyword int and then you specify an identifier for the integer. Okay, so then a is a variable of type int that would be created in RAM. Now we want to create a variable of type my time. Okay, so how can we do that? So what is the data type? My time. This is the new data type that we created, and let us call the variable as t1, my time t1. So t1 is a variable of type my time. T1 is a variable of type my time. Okay, so let's see, what does t1 have? What are the values stored in t1? Okay, so t1 is equal to basically, sorry, t1 is equal to, so t1 is basically nothing but its data members. So t1 is of type my time, and it has these three data members: hours, minutes, and seconds. So the variable t1, when it is created, it will have three integer data members. One is used to store hours, the other minutes, the other seconds. You can access these individual data members using the member access operator. What is the member access operator? So we have in C++, we have two member access operators. One is the dot member access operator, the other is the arrow member access operator. Okay, so here how you can use these two member access operators. So if you have a variable of type my time, and you want to access the individual values of the individual data members of my time, like hours, minutes, and seconds, what are their values? So you can use the dot member access operator. You can say t1 dot hours. So we want to print on the screen all these values, t1 dot hours. Then we want to print this thing. Then we want to print t1 dot minutes. Okay, then we want to print this thing, and then we want to print t1 dot seconds. Okay, and then we want to have a new line character. Okay, so this dot is the member access operator. Okay, so if you have a variable of type my time, and you want to access its individual data members, so you can use the dot member access operator. You can say t1 dot hours, t1 dot minutes, t1 dot seconds, and you will be able to access the values of the hours, minutes, and seconds data members directly. Now, as you know, like we did not initialize these values. So here, just like any other variable, we expect these values to be garbage values. Okay, so when you compile this program and then build and run it, so you'll see garbage values on the screen because you did not initialize these data members. So t1 would be some garbage value. Okay, so these are not that garbage, but still this is good garbage. Like it looks, these are garbage because we did not initialize these values, we did not assign these values, they are not automatically initialized to some fixed value, but these are good garbage values. Although this may not be a guaranteed outcome all the time, but right now you're going to get it this way. So I hope like you know what happened here. So when you build and run this program, so on the output you see t1 is equal to 0 hours, 16 minutes, and 0 seconds. Now these are garbage values. We did not initialize this variable to these values, and this is what you see. If you want to assign some values to the different data members of t1, so you can do that. You can say t1 dot hours. So you can say right now, say for example, it is 6 hours, and then t1 dot minutes. It is, say for example, 25 minutes, and then t1 dot seconds. Say it is equal to, say, 43 seconds. Okay. So this is how we initialize the values of each data member of t1, and then when we run this code, so now when we print t1, so these values would be printed 6, 25, 43. Okay, so let us compile our code and then build and run it. So now when you print t1, so it says 6, 25, 43. Okay, so this is how you can initialize it with values of your own choice. Okay, now we said that in C++ we have two member access operators. So we talked about the dot member access operator. We used it. Okay, so why do we need member access operators? Because a structure, it has different data members of which can be of different data types. So the data type of data members is not important here, but a structure can have different data members, and you might need to, and you will need to access these individual data members. If you need to access individual data members, how can you do that? So for that we have member access operators. So we have a variable t1 of type myTime, and we want to access its individual data members, hours, minutes, and seconds. Okay, so whenever you create a variable of type myTime, each variable of type myTime will have these three data members. Okay, so these are three integers. So a variable of type myTime is going to use around 12 bytes, 4 bytes per integer, and there are three integers, so it will have uh, 12 bytes of memory. Okay, so you can find it out, you can verify it. Size of t1. Okay, so t1 is a variable of type myTime, so its size is equal to, so we can use the size of operator, and we can find the size of t1, and the size of operator returns us the size in bytes. Okay, so it returns us the size in bytes. So the size of t1 or any variable of type myTime, it is going to be 12 bytes. Okay, size of t1 is equal to 12 bytes. Why? Because t1 is a variable of type myTime, and myTime is a structure or an aggregation of three integer variables. Okay, so that's why its size is 12 bytes. Okay, so this is one member access operator, the dot member access operator. The other member access operator is the arrow member access operator. And when do you use the arrow member access operator? So this is when you use it. This is when you use the arrow member access operator. So I hope you know what a pointer is. Okay, so a pointer is a variable that is used to store the address of another variable. So a pointer does not store data or value. It stores an address. Okay. Say for example, here we have a variable. This variable stores data. Okay, it stores a value. Similarly, we have this t1.r. It is an integer value variable that stores data or value. It does not store an address. Okay. So in C++, we have these other types of variables which can store addresses, and those variables are called pointers. Okay, so I hope you know pointers, and I hope you know how to declare and initialize a pointer. So let me declare a pointer to a variable of type myTime. So we have this variable pt. Okay, now this is a pointer. Okay, how did we make it a pointer? By using this asterisk character here. So we just turned it into a pointer. So this variable is going to store the address of a myTime variable. Okay, so it's going to point to a myTime variable. It is not a myTime variable by itself, but it is a variable that can store the address of a myTime variable, okay, a variable of type myTime. So let us initialize it with the value with the address of t1. So how can you do that? Using the address of operator, using the address of operator. So we have this variable pt, it is a pointer, and its type is myTime, which means that it will point to a variable of type myTime, or it will store the address of a variable of type myTime. So we initialize it with the address of a variable of type myTime, and that variable is t1. Okay, that variable is t1. So we use the address of operator to get the address of t1 and copy that address into pt, which is a pointer of type myTime. Okay, now we can access the data members of t1 using this pointer. How? So this is how we can access it. So let us say, uh, let us print this message: accessing t1 using pointer pt. Okay, so let us first print this message. It's not important to print this message, but just to, and let us see if we can do that. So let me copy this line, and sorry, let me copy this line and paste it here. So we want to access t1 using the pointer pt. How can we do that? This is how we do it. So we want to use pt to access data members of the myTime variable t1. Okay, so we want to do that using the pointer pt. So if you have a pointer and using that pointer variable you want to access the data member of some structure, so then you cannot use the dot member access operator. Okay, then you will have to use the arrow member access operator, and you can print the arrow member access operator by first printing the dash and then the greater than sign. Okay, so when you do that, the arrow will be complete and the editor will show you कि किस data member को आप access करना चाहते हैं, which data member do you want to access. So we want to access hours, ठीक है, and then we want to access minutes. So after hours we want to print this thing, then we want to access minutes, pt arrow minutes. Okay, then we want this thing to be printed, then we want to print pt arrow seconds. Okay, so we can access the data members of a myTime variable using the arrow member access operator. Okay. When do you use the arrow member access operator? When you use a pointer to access the data members of some structure. Okay, so now we have this pointer variable pt. It has been initialized with the address of t1, this particular structure, and we want to use this pointer to access the data members of t1. So if you were using t1 directly, you use the dot member access operator, but if you are using pointer to this structure t1, so then you use the arrow member access operator. Okay, so you should be aware of these two member access operators, dot and arrow member access operators. You use the dot without pointers, and you use the arrow with pointers. Okay, so this is how you should remember it. And you'll see the output of both these statements would be the same because we are accessing the same object. We only have one structure of type myTime. Okay, this is not a structure. This is pointer to a structure of my point type myTime. Okay, so this variable basically stores an address. It does not store. It stores an address of a variable of type myTime. It does not store the myTime structure itself. This is the structure. Okay. So I hope like you can make this distinction. So let us compile this thing. and then build and run it. So this is the output. This is going to be the output T1, and then accessing T1 using pointer PT. You're accessing basically the same object. Size of T1 is equal to 12 bytes. What would be the size of PT? Now the size of PT will not be 12 bytes. Okay, it is an address, so it would be around 4 bytes. Okay, on a 32-bit system, it should be around 4 bytes. On a 64-bit system, it should be around 8 bytes, but that is not how it may be. Okay, internally things can be treated differently, and the addresses can be quite different. Okay, so it would be around 4 bytes. The size of pointer PT would be around 4 bytes. Let us compile this code and then build and run it. 8 bytes. Okay, so the size of PT is 8 bytes. Now pointer, it is a pointer, it stores an address, and how is that address stored? Now this value can differ depending upon the type of system that you're using, 32-bit system or 64-bit system, and depending upon which address is stored in the pointer and which address is being printed. So but it is not 12 bytes. The important thing is the size of PT is not 12 bytes. Why? Because PT is not a variable of type uh, of type my time. It does not store um, like the values of the my time structure. It is basically a pointer to a variable of type my time. It stores the address of a variable of type my time. Okay, so there is a difference between the two. One stores a value, T1 stores the value, and PT stores the address. So that's why you see the difference between these two. They are not the same. These variables are not the same. Okay, so I hope like using these two examples, you know how to create a struct and how to use that struct. Okay, so we created the struct my time, and here we used uh, we use that variable that structure my time. Okay, the next thing that we want to do is we'll write this function inside the we'll create these two functions inside the my time uh, structure. I'm going to write first the function print. Why? Because you can see here like we are doing this printing T1 को पहले we are printing T1 here using T1 itself and the dot member access operator, and then we are printing T1 using the pointer PT. So and we are repeating this code like we are writing this thing here and then here again. Okay, so let us make things simpler. Let us create a function print inside the structure my time. That function would directly uh, print this variable, this any structure my time for which it is invoked. So the print function is supposed to print the value of hours, minutes, and seconds on the screen. It is not supposed to return anything. So that is why its return type is void, and this is a function. Okay, so it is going to be a block of code, and what is it going to do? Okay, it's just going to do this thing. So let me copy this line and paste it here. So we are going to print. What are we going to print? T1.hours, not T1.hours, just hours. Okay, so whether it is T1.hours or T2.hours, so that will be specified later. So if this function is invoked for a variable T1, then T1.hours, hours data member of T1 would be printed. Okay, if it is invoked for T2, a variable T2, then the R's data member of T2 would be printed. Okay, so here we do not need to specify T1, T2 or T3 or anything. So for whichever data, for whichever my time object it is invoked, okay, so that value would be printed. For example, let us create another my time object T2. Okay, so T1, T2. So if we say T1 dot print, now let us get rid of this thing. Now we don't need it. Similarly, let us get rid of this thing. We don't need this one either. Okay. So we can say T1 dot print. So this will print T1. And we can also say T2 dot print. Now this would print T2. So when we call the print function for T1, so this print function will have access to the hours data member of T1, the minutes data member of T1, the seconds data member of T1, and those data members would be printed. When we say T2 dot print, so the print data function, so the print member function, it will have access to the hours data member of T2, the minutes data member of T2, the seconds data member of T2, and it will print that. Okay. So let us inform the users that we are printing T1 or T1 is equal to. Okay. So we are printing T1 is equal to, and then T2 is equal to. Okay. T2 is equal to. Let us comment out this line as well. So compile this file and build and run it. Okay. So here you can see T1, when we say T1 dot print, so T1 is printed. When we say T2 dot print, so T2 is printed. And here we have these garbage values. Okay. We have these garbage values, T2 dot print. Understand? So the print function, it works fine whether you call it for T1 or T2. When you call it for T1, the print function has access to the data members of T1, the my time variable T1. When you say T2 dot print, so the print function has access to the data members of T2. So here inside the print function, you just need to say print cout hours, minutes, and seconds. You do not need to say cout T1 dot hours or T2 dot hours or T1 dot minutes or T2 dot minutes. Okay. So for whichever variable this function is invoked, this function has access to the data members of that variable. Okay. Similarly, you can call it using like we can say T1 dot, we can print T1 by invoking the print function using the pointer PT. We can say PT arrow print. Okay, we can say that. So we can say PT arrow print. PT stores the address of T1. So we can print T1 by using the pointer to the T1 structure. Okay, so we can say PT arrow print. We can do that, and the result will be the same. Okay, so the program is still running. That's why we couldn't compile it. Let us build and run. So T1. So this statement cout T1 is equal to PT arrow print. So it prints T1, and then T2 is equal to T2 dot print. That prints T2. Okay, so it works fine. Now I'll add just one more function to the my time class, and that function would be the add function. If you want to add two intervals or two time objects, like, then how can we do that? So we want to create the add function. Now I have provided that code here as well. So the add function is going to add two intervals. the intervals are stored in the structure myTime, and once you add two intervals, you get an interval as a return. Okay, so the add function, it will not be like void. It will not just return void or nothing. It will return a myTime uh, structure. Okay, it will return a myTime structure. So this add function is going to add two intervals. Okay, so both are going to be structures of type myTime. Okay, so now here I'm going to although like you would think कि ऐड जो है, चूंकि हम दो चीज़ों को ऐड कर रहे हैं, तो ये जो ऐड फंक्शन होगा इसके दो इनपुट्स होने चाहिए या दो आर्गुमेंट्स होने चाहिए. Since we are adding two intervals, so we might think that the add function should have two input arguments. ठीक है? Because you always add two things to uh, get to get to get a new value. Okay, so addition is a binary operation. So जब भी आप addition कर रहे हो, so you need to add two quantities together. So the add function, you might think that it should have two arguments. It should have, say for example, uh, operand 1 of type myTime, and it should have another operand 2 of type myTime. Okay, so this is how the add function should look like. You might expect कि इस तरह से होना चाहिए add function को. So we should be adding operand 1 and operand 2 and then returning its sum, their sum. Okay, this is how the add function should be. But if you look at the print function, what did the print function do? It printed a myTime variable. ठीक है? And it printed one myTime variable, but we did not pass that variable. हमने वो variable इसको as an input नहीं दिया था. ठीक है? तो फिर वो variable आया कहाँ से? So you see in the main program, when you say t2.print, when you call the print function for t2, ठीक है? So the print function has access to the data members of t2. It has access to the hours, minutes, and seconds data members of t2. If you say t1.print, so the print function has access to the data members of t1, hours, minutes, and seconds. Similarly, the add function, when we would be calling or invoking the add function, we would say t1.add or t2.add or pt arrow add. So when you call the add function for t1, so it will have access to the data members of t1. If you call the add function for t2, it will have access to the data members of t2. ठीक है? So जब भी आप add function को call करेंगे, इसके पास access होगी एक myTime variable के data members तक. ठीक है? So आपको यहाँ पे दूसरे दो arguments नहीं चाहिए. You only need one argument. Okay? कैसे आपको सिर्फ एक argument चाहिए? वो यूं चाहिए. Okay, for example, you would say t1 dot add. t1 के साथ add करें किस चीज़ को? t2 को add करें. ठीक है? So we have these two objects. Yeah, इसको I'm going to cut this thing and bring it here. So let's say we have another variable myTime t3, and t3 is equal to t1 dot add t2. So we want to add t1 and t2 and store the sum in t3. That is what we want to do. And if you want to add t1 and t2, you have to call the add function. Add function को call करने के लिए या आप लिखेंगे t1 dot add या आप लिखेंगे t2 dot add. ठीक है? अगर आप लिखते हैं t1 dot add तो आर्गुमेंट में फिर t2 पास करेंगे, और अगर आप लिखते हैं t2 dot add तो आर्गुमेंट में फिर t1 पास करेंगे. यानी you can have these possibilities. You can say t3 is equal to say t2 dot add t1. ठीक है? Acha. What happens when we call add function this way? What happens when we say t1 dot add t2? तो ऐड फंक्शन में T2 जो है ना वो कॉपी होगा इनटू op1. Structure is passed by value. Here when you say T1 dot add T2, so T2 जो है it is a variable of type my time, and it would be passed to the add function by value. तो T2 की एक कॉपी बनेगी और वो कॉपी हो जाएगी into op1. So op1 will contain the copy of T2. ठीक है. अच्छा, और अब यहाँ आपने लिखा है T1 डॉट ऐड, तो ऐड फंक्शन को कॉल किया जाएगा फॉर T1. दैट मीन्स कि ये जो आवर्स मिनट्स और सेकंड्स हैं, these will have the values of T1 dot hours, T1 dot minutes and T1 dot seconds. ठीक है. तो hours, minutes और seconds में you will have the values of T1 dot hours, T1 dot minutes, T1 dot seconds, and op1 will have a copy of T2. So op1 dot hours, op1 dot minutes, op1 dot seconds. That way you can access the hours, minutes and seconds of क्या कहते हैं the other object T2 जिसके साथ आप ऐड कर रहे हैं. अगर आप इसको यूं कॉल करते हैं T3 is equal to T2 dot add T1, तो T1 की कॉपी बनेगी और वो होगी into op1, और चूंकि आप ऐड फंक्शन को कॉल कर रहे हैं फॉर T2, आप कह रहे हैं T2 डॉट ऐड, तो आवर्स, मिनट्स और सेकंड्स जो वेरिएबल्स हैं इसमें वैल्यूज होंगी T2 के आवर्स, T2 के मिनट्स और T2 के सेकंड्स की. ठीक है. So I hope like if this is not clear to you, you should rewind this part of whatever I said and listen to it as many times as you need to, so that it's clear to you कि ये हो क्या रहा है. ठीक है. I hope यहाँ से आपको clear हो जाएगा, because whenever you call the print function, if you call the print function for T2, so print function has access to data members of T2. If you call the print function for T1, either using a pointer or using T1 itself, the variable T1 itself, so then the print function has access to the data members of T1. ठीक है. Similarly, ये जो add function है, if you call it using T1, so it will have access to the data members of T1. If you call it using the variable T2, it will have access to the data members of T2. और जो दूसरा वेरिएबल है वो आप एज एन आर्गूमेंट फिर पास करते हैं, उसकी कॉपी आएगी op1 में. ठीक है. अच्छा, so now we need to find the sum. ठीक है. Sum would be a variable of type my time. So let us create it. Sum is equal my time sum. अच्छा, सम का हमने ये तमाम पार्ट्स कैलकुलेट करने. ठीक है. We need to find seconds, minutes, hours. So whenever you are adding to intervals, you first add the seconds, then add the minutes, then add the hours. ठीक है. So how do we do it? ठीक है. So first of all, seconds. Again, ये the point is not like mathematical correctness, how correct we do, although this is very important, but here I'm not, this is not my primary concern कि मैं ये जो काम कर रहा हूँ ये mathematically बिल्कुल correct हो. I'm just trying to teach you how to write functions that work on variables of type, variables of these new structures that we create. ठीक है. So हमने ये structure my time create किया, and now we are writing functions, member functions within this structure my time, which operate on variables of type my time. ठीक है. So how to write such functions, that is the primary concern. ये जो calculations हैं इनको correct होना चाहिए, that definitely, this is what computing is for. This is why we are using computers, and this is what data processing is. But this is not my primary concern right now. So this algorithm might not be perfectly fine. So you can think about it. You'll have plenty of time to think it over. But हमने पहले seconds को add करना है. तो seconds को add आप करते हैं, अगर seconds का sum it exceeds for example 60, तो that it becomes 1 minute. ठीक है. और वो minutes जो है ना, फिर वो minutes के साथ हमने add करने हैं, और उससे जो बच जाए, for example आपके पास एक इंटरवल में सेकंड्स हैं 50, दूसरे इंटरवल में भी सेकंड्स हैं 50, तो 50 plus 50 is 100. Now we cannot have 100 seconds. 100 seconds means 1 minute and 40 seconds. So seconds में हमारे पास 40 होना चाहिए, और वो जो एक मिनट है that should go into the minutes part. ठीक है. So वो हम कैसे कर सकते हैं, तो sum dot seconds पहले मालूम करेंगे. ठीक है. सो सम डॉट सेकेंड्स इज बेसिकली हमारे पास ये जो सेकेंड्स हैं, ये वाले सेकेंड्स, ठीक है। ये वाले कौन से सेकेंड्स होंगे? तो से फॉर एग्जांपल आप कहते हैं t1 डॉट ऐड t2। सो जब आप ऐड फंक्शन में आएंगे तो ये जो सिंपल आपके सेकेंड्स हैं ना, ये t1 के सेकेंड्स होंगे, और t2 के सेकेंड्स कहाँ होंगे? वो op1 में होंगे। तो फिर आप कहेंगे जी प्लस op1 डॉट सेकेंड्स, तो ये t2 के सेकेंड्स होंगे, ठीक है। सेकेंड्स प्लस op1 डॉट सेकेंड्स, तो ये t1 के सेकेंड्स होंगे, ये t2 के सेकेंड्स होंगे। इन दोनों को ऐड करें और फिर इनका मॉड्यूलो लें विद 60, यानी 60 से डिवाइड करें और रिमाइंडर लें, तो वो आपके सेकेंड्स, सम के सेकेंड्स हो जाएंगे। कैसे? अगेन मैं आपको वही एग्जांपल रिपीट करता हूँ। से t1 के सेकेंड्स हैं 50, t2 के सेकेंड्स हैं 50, 50 प्लस 50 इज 100, 100 is basically 1 minute and 40 seconds. So in the seconds part we should have 40 and 1 minute should go to the other, the minutes part. So how do you get 40? अगर आप 100 को 60 से डिवाइड करें तो रिमाइंडर इज 40. So this is why how we find the remainder. ये मॉड्यूलो ऑपरेटर है, ये रिमाइंडर मालूम करके हमें देता है, ठीक है। So this should go here, और वो जो 1 मिनट बचा है ना, that should go to the minute part, ठीक है। तो वो आप अभी से कर लें, अभी से, ताकि बाद में आपसे गलती ना हो, ठीक है। इसको मैंने कॉपी कर लिया। सो लेट अस कैलकुलेट द मिनट्स, सम डॉट मिनट्स। सो उसमें एक कंपोनेंट तो ये होगा सेकेंड्स प्लस op1 डॉट सेकेंड्स। अब ये मॉड्यूलो नहीं होगा, ये वो डिवीजन का रिजल्ट होगा, ठीक है। रिमाइंडर सेकेंड्स में असाइन हो जाएगा, कोशंट जो है वो मिनट्स के साथ ऐड होगा। तो मिनट्स जो है ना, एक तो यहाँ से डिटर्मिन होंगे, दूसरे कहाँ से डिटर्मिन होंगे? दूसरे हमने मिनट्स को आपस में भी ऐड करना है, ठीक है। और जब वो ऐड हो जाए तो फिर उनका मॉड्यूलो लेना है विद 60, ठीक है। और ताकि आवर्स का भी पता चले। फॉर एग्जांपल हमारे पास 50-50 मिनट्स हैं, तो 50 मिनट 50 मिनट ये हो गए, 100 मिनट 100 मिनट का क्या मतलब? 1 घंटा 40 मिनट, ठीक है। तो अगेन वही प्रोसीजर होगा। सो हेयर वील हैव मिनट्स, कहाँ गए मिनट्स प्लस op1 डॉट मिनट्स, ठीक है। सो op1 के मिनट्स को हम ऐड करते हैं, मिनट्स को हम ऐड करते हैं। अच्छा, फिर ये सेकंड्स, इससे जो मिनट्स आए, ये तमाम जो मिनट्स हमारे पास बनते हैं, ये तमाम मिनट्स, इनका मॉड्यूलो लेंगे हम विद 60, ठीक है। सो दीज विल बिकम आर मिनट्स, ये हमारे मिनट्स होंगे। अच्छा, इसका एक कुछ कंपोनेंट हम आवर्स में यूज़ करेंगे। सम डॉट आवर्स इज इक्वल टू, ये जो हमने मिनट्स के साथ काम किया है ना, इसमें से कुछ घंटे भी निकलेंगे। अच्छा, वो से यहाँ हमने मिनट्स में, अच्छा मिनट्स को असाइन कर दिया, और ये जो वैल्यू है, एक सेकेंड, ये वैल्यू डिवाइड बाय 60, यू कैन थिंक इट ओवर कि ये कैसे काम कर रहा है, बाद में आप इस पर ज़रा सोचें। अच्छा, ये आर्स कुछ यहाँ से हमारे पास आ गए और कुछ आर्स यहाँ से आएंगे। कहाँ से? हमने आर्स को ऐड करना है विद with what, with op1 dot hours, ठीक है। तो यू वेरीफाइड कि ये जो मैं एडिशन कर रहा हूँ ये ठीक कर रहा हूँ या नहीं कर रहा। मे बी मैं ठीक कर रहा हूँ, मे बी देयर इज सम मिस्टेक। सो दिस इज पार्ट ऑफ योर होमवर्क टास्क के आप इसको करेक्ट कर लें कि दिस इज फाइन। So once I'm done calculating all the data members of sum, I would return the sum, ठीक है। अच्छा जी, ये हो गया। Now let us test this routine. So हमारे पास T1 ये है, let us T2 को भी इनिशियलाइज कर लेते हैं, T2 को भी इनिशियलाइज कर लेते हैं। अच्छा, So let us say t2 dot hours, this is t2 dot hours, t2 dot minutes, t2 dot seconds, ठीक है. So ये जो इंटरवल है, say for example it is 8 घंटे 50 मिनट और 50 सेकंड्स हैं, और ये जो इंटरवल है वो 6 घंटे 50 मिनट और 50 सेकंड्स, ठीक है. So let's say this is what they are. अच्छा जी. So let us find t3. t3 हम यहाँ पे मालूम कर लेंगे as t1 dot add t2. t1 को प्रिंट किया, t2 को प्रिंट किया, and then we need to print the sum. ठीक है. cout t1 plus t2. ठीक है. This is what we want to print, is equal to, and then let us print t3 dot print. ठीक है. So let's see कि ये sum हम ठीक कैलकुलेट कर रहे हैं या नहीं. Let us compile it. अच्छा, and let us build and run. अच्छा जी. So this is t1, 8 घंटे 50 मिनट और 50 सेकंड. This is t2, 6 घंटे 50 मिनट और 50 सेकंड. अच्छा, अब इनको जब ऐड करेंगे तो कैसे करेंगे? तो पहले आप सेकंड्स को ऐड करेंगे. ठीक है. तो 50 और 50 सेकंड, ये 100 सेकंड बनते हैं, लेकिन 100 सेकंड जो है ना वो बेसिकली 1 मिनट और 40 सेकंड हैं. तो 40 सेकंड रह जाएंगे और 1 मिनट यहाँ कैरी हो जाएगा. 50 और 50 100 मिनट, और एक वो पिछले वाला 101 मिनट हो गए. 101 मिनट बेसिकली 1 घंटा और 41 मिनट हैं. तो 41 मिनट यहाँ रह जाएंगे, 1 घंटा यहाँ कैरी कर जाएगा. सो 8 जमा 1 9, 6 15, 15 घंटे. ठीक है. सो वी आर डूइंग समेशन हम ठीक कर रहे हैं. अच्छा, समेशन हम क्यों ठीक कर रहे हैं? यू शुड लाइक, ये जो कोड मैंने लिखा है, यू शुड पे अटेंशन टू इट कि ये कैसे काम कर रहा है. ठीक है. अच्छा, अब मैं आपको यहाँ पे ये जो ऐड फंक्शन है, इसके अंदर हम एक काम करते हैं. ठीक है. व्हाट इज इट? विल बेसिकली यहाँ पे एक चीज़ प्रिंट करते हैं, सी आउट. ठीक है. op1 इज इक्वल टू, अच्छा जी, and then we say op1 dot print. So we are basically printing op1. We are printing op1. ठीक है. This is what we are doing. अच्छा, first we are calling this function t3 is equal to t1 dot add, और t2 हम उसको पास कर रहे हैं. then we say t3 is equal to t2 dot add और t1 पास कर रहे हैं. तो यहाँ पे जब add कॉल होगा तो पहले t2 एज एन आर्गूमेंट पास होता है. t2 will be copied into op1. जब आप op1 प्रिंट होगा तो बेसिकली t2 प्रिंट होगा. और सेकंड केस में t1 is passed as an argument, so it will be copied into op1. so जब op1 दूसरी केस में प्रिंट होगा तो t1 प्रिंट होगा. ठीक है. अच्छा, so t1 और ये जो वैल्यूज है ना, ये सेकंड्स और मिनट्स, और ये फिर हमारे पास इस ऑब्जेक्ट के हैं जिसके लिए इस फंक्शन को कॉल किया जाता है. तो पहले केस में hours, minutes and seconds, they are from t1, और दूसरे केस में वो t2 से. Let us compile it and build and run it. ये सिर्फ आपको समझाने के लिए मैंने ये changes किए हैं. So here you see op1 6 50 50. So that is basically t2. ठीक है ना. तो पहले हम कहते हैं t1 डॉट ऐड और उसको t2 पास करते हैं एज एन आर्गूमेंट. फिर दूसरी मतलब हम कहते हैं t2 डॉट ऐड और t1 पास करते हैं एज एन आर्गूमेंट. सो नेक्स्ट टाइम जब वो कॉल होता है तो op1 में t1 की वैल्यू प्रिंट होती है. ठीक है. सो लिसन टू वट एवर वी जस्ट डिस्कस्ड एंड रीड आउट दिस हैंड आउट. और ये जो कोड मैंने लिखा है यहाँ पे ट्राई इट आउट and then complete the other task. Next उसमें मैं आपसे एक कहा गया कि आप subtract function लिखें. subtract function should do the subtraction. So subtraction is also similar, but वहाँ पे आपको carry के बजाय borrow को देखना पड़ता है. So you do the subtraction seconds, पहले subtract करते हैं seconds से. अगर वो नहीं हो सकते तो you borrow from minutes, और फिर minutes को minutes से वो नहीं हो सकते तो you borrow from hours. ठीक है. So it is slightly more complicated but doable. कोई इतना बड़ा मसला नहीं है. Task 3 में I ask you to create a new uh, uh, new structure called my complex, और उसके लिए कौन कौन से फंक्शन लिखने हैं, उन फंक्शन में करना क्या है. टास्क 4 में आई आस्क यू टू क्रिएट another structure fraction. ठीक है. तो hopefully this would give you enough practice with structures. ठीक है. So this is all that we have for lab 1. Again, it has nothing to do with object oriented programming yet. We haven't talked about that, but you can do it without knowing anything about that. Structures is a standalone concept, and you can use it. Okay, so you can use this code, you can recreate this whole code, and you can complete all the tasks without having to resort to any other concept. आपको उनकी समझने की फिलहाल ज़रूरत नहीं है. So all you need to do is put your background in computer programming and this knowledge that you might have gained or gleaned from this video lecture and the handout, and use it to do all these tasks. ठीक है. So that's it for now.